Okay, let's get started on this. I usually show this presentation in Pro, but it looks like I have a dev build of Pro, which is my fault. I should have installed like a stable build of Pro. So I'm going to talk a little bit about Python raster functions. How many of you have played with Python raster functions? Oh, quite a few. Good, awesome. So I'm gonna go over this as quick as I can because this used to be a tech workshop as well. I'm going to give you a quick introduction of functions, and then I'm going to talk about the API itself a little bit, and I'm going to talk a little bit about building raster models using the Python raster function API, and a few other things. So, what is a raster function? It's a mapping of one raster to another. So this is all done typically in memory, although with the dawn of raster analytics, which you've probably heard a bit about lately, we can actually use these to write physical rasters to disk as well. They also can sit on top of a mosaic data set. If you were in my previous presentation, they also sit there too. So it's like a first. It's something that's used quite a bit. It's kind of our new processing story for rasters at this point. It is different from a geoprocessing tool. A lot of people get confused and like, well, I want to put this function into my GP model, but it's not working. So it is a completely separate thing, although we have a few tools to transition between the two. You probably heard about this generate raster GP tool. It will actually make a function into like a GP tool. You can chain functions together like GP tools. The function editor looks fairly similar to the GP model builder, which is probably why people are getting confused. So yeah, it can just sit on top of a raster. You can ingest a raster in and now put a function raster. You can put it on top of an item in a mosaic data set, so not necessarily on top of the mosaic data itself, but you can do it as an item. It does sit on top of a mosaic data set, and you can apply them to image services as well. So here is what a basic, this is not basic, this is actually the Landsat 8 pan-sharpen raster function template. So it's just taking all the bands, getting the info from them, making composite bands, extracting the pan-sharpen band, extracting the multispectral product, and creating a pan-sharpen product from that. So that's what a pretty basic function template looks like. Okay, so let's get into what's really important here, and that's the Python raster function. So the Python raster function is the same thing. We have a bunch of Python code sitting somewhere. It plugs into this adapter function, and then it sits in a function template just like any other function. It's a first-class item, just like any of the out-of-the-box functions. So you as a developer needs to know how to construct these Python functions, but the end user sees it as just a regular function like anything else. So let's take a look at the same model but with a Python function. So here, this cog right here is a Python function. It's the adapter function. We have your Python code here. We have the adapter function, and then it just sits in a model just like anything else. And again, it can be used across the board with your raster data sets, mosaic data set items, mosaic data set, and image service. So why'd we do it? We did it in Python because we could make custom functions in C# back in the day, but a lot of the cool libraries and modules that Python have just weren't accessible through that. So we got a lot of push from people to implement this in Python, just because you can use scikit, learn, numpy, scipy, all those cool Python libraries that just weren't available. So why we did it? We want people to be able to build their own functions. We have a bunch of out-of-the-box functions, but there's just so much more that you could do, and people wanted to be able to build their own. And we did it in Python again because it's easy to learn and people are comfortable with it. So how do I create it? So we have a GitHub page. I can show you the URL to it. That's a good start. So we have code samples of kind of everything. We have some that do like sliding windows that slide across rasters. We have stuff that do band arithmetic. We have things that do a bunch of cool stuff. So that's a good starting point. Go to the the GitHub repo, grab some of the sample scripts and take a look at them. And there's a bunch of API doc in there as well. We're documenting it all through GitHub because it's easier for us to manage. What additional libraries are needed? None, unless you're building something that requires it. So if you're going to start doing stuff, I mean, ArcGIS Pro and Desktop now come with a fair amount of Python libraries installed, like SciPy and NumPy. They're already in there. If you're using something that maybe we don't install, then you just need to make sure that everybody has it. If you're going to send this Python function to somebody, then you're going to have to make sure that they have that module installed as well. So let's look at the basics. So here is a basic function. So here's the class, which is our function. We have to define the init method, which is we'll store the name of the function, the description if need be, and then parameters, and then UpdatePixels. UpdatePixels is where we do the work. That's where all the image processing happens. Here's a basic one that's just taking the input pixel block and adding 10 and then outputting something. So here's the init method. The init method has the name of the function, which when a user opens it, they'll see it. It'll have the description of the function, which will be here. This output pixel type is actually not in there. So this is the basic initializer method. It has to exist in every Python function. The second thing is the GetParameterInfo method, and this is where we define all the parameters that are getting passed into the function. So, and I'll show you a code sample of this. So each parameter has several properties. The name, the display. So the name is the thing you're going to use down the road. So you're going to be using that down the road in your Python code. The display name is what the user is going to see. So the display name here is slope raster. It's something a little more user-friendly, not like a Python variable that you use. The long description, if they hover over the parameter, it'll give them a description. It's kind of like, what does that parameter do? The data type, so what kind of data is it? Currently, we support numbers, strings, rasters, an array of rasters, and I think that's it right now. If we're talking about implementing geometry at some point, that's something. Right now, you have to convert your geometry or your shape files or feature classes to raster. There's a function that does that, but I think eventually we want to be able to pass geometry into these as well. So we're going to keep growing this list of parameter types. Okay, the next one is GetConfiguration. So this is how we manage. So remember, these are virtual rasters. We're creating these rasters in memory, so we need to construct an output raster before we start manipulating pixels in it. So we can put padding and masks. So padding is if I'm doing a sliding window, I might want to pad the window. We can do masking. We can inherit properties from a parent raster. So if I'm putting in a Landsat image, I can say, okay, I want to inherit the bit depth. I want to inherit the resampling. I want to inherit just a bunch of stuff, whatever you want from the parent raster. And I can also invalidate properties. So by default, it's going to take everything from that parent raster. We can invalidate properties too. We can say, okay, I want you to invalidate the bit depth because it's going to be a new bit depth. Maybe I'm doing an NDVI on Landsat. It's not going to be 8-bit anymore, right? It's going to be 32-bit because it's NDVI. So I can invalidate all those properties. I can set the resampling type, and I can extract and composite bands in there as well. Select rasters. Not a lot of people use this, but I think it's kind of handy. We can actually define what so given an array of rasters, we can actually define what parts, what items in, say, that stack of rasters we want. So we don't load it all into memory. We can just select maybe 2 and put them into memory. Otherwise, the whole stack will go in there, and then you have to filter through that later. Fairly useful for optimizing performance. Not a lot of people use it, though. UpdateRasterInfo. So this is really where we physically define the output raster. We can define the band count, how many bands are in it, pixel type, what the no data value is. So we're going to define all the properties of the output raster before we start pumping pixels into it. And then the UpdatePixels method. The UpdatePixels method is the workhorse of the Python raster function. This is where you're going to do all your image processing algorithms. This is where you're going to put all the code. So yeah, and I'll show you that in a bit. And then the UpdateKeyMetadata method, we can actually rewrite key metadata properties. So all these rasters have key metadata like sensor name, sensor sun azimuth, all the different information. You can actually go in and overwrite those in the output as well. So given maybe it's a Landsat product, maybe you want to do a bunch of stuff to it and output it. You don't want that band metadata in there anymore necessarily. So you can invalidate that or rewrite or overwrite some of it. Is licensed. So is licensed, we can actually crawl through licensing and make sure the user is able to run a particular function given the license level they have. So if they're at basic and they don't have spatial analyst and you're doing a bunch of stuff, we can actually go through and determine if the user is licensed to use it, and it'll return a Boolean whether it's okay to run it or not. So you can access stuff like product name, version, major, minor, version numbers, stuff like that. And that's about it. So let's look at an example of the Python raster function. I'm going to do this on a compound topographic index. So what a compound topographic index is just essentially a measure of wetness in a particular area. It takes a slope raster and a flow accumulation raster as an input. It's used in the hydrology world. I don't want to dwell too much on what this is. I just want to kind of show you how it works in Python. So here's the basic formula for CTI. Here's how it's going to look. I'm going to take flow accumulation raster, slope raster. I'm going to have my Python code in the background, plugged in the adapter function in my model, and it's going to output a CTI raster. Here's kind of what it looks like in code. Here's what you'll see in the UpdatePixels method, which is kind of the workhorse of the Python function. Pretty basic code. And I'll show you how to do this. So my pro is not working. So I apologize. I'm going to have to do this in 10, which is a little clunkier, but do you guys use 10 or pro for Python for functions? Are you guys using 10 still? 10? Yeah.
Pro crashes.
Pro crashes, that's right. Don't use pro. No, it's an unstable. It's like yesterday's build, so my bad for using that. Anyway, it works in both. The great thing about Python raster functions is it works in both. So to access a Python raster function, what we do is, here you can see insert Python raster function. So all you have to do is point to your Python module. So I have it sitting so here's my Python file. So you can see it kind of populated. So I'll show you I'll show you the Python code real briefly. I don't have much time. So here I have my init method. Again, I just have the name of it and a short description, which will show up in the help. Here I'm defining the two parameters, both rasters, both slope rasters. Here's the name I'm going to use. Here's the display name, so it's a little different from the name itself. Here I'm invalidating and inheriting properties from the parent raster. Here I'm defining the output, so it's going to have one band. I know what the output values are going to be, so I'm going to pre-cook the statistics in there. I'm going to set the cell size. And here's my UpdatePixels. So essentially, we're calling it down here. Here's the code I'm calling, but here's the actual function that I'm using right here. And then I'm going to update key metadata, and that's basically it. So let's take a look at it. I'm going to point to my two rasters. The first one is my slope raster, and the second one is my flow raster. I'm going to run it. Layer, why is it not working? Oh, it's drying. It's taking a lot longer than it should. There we go. It's drawing now. Zoom out a little bit. All right. So here's my compound topographic Windex raster. It renders fairly quick. This is all happening on the fly. It's not really right now, but as you pan and zoom, it's actually calling this Python function and rendering it on the fly. So that's a basic how-to. Same thing works in Pro when it's not crashing. Okay. So I want to talk a little bit about how we build templates with these things. So typically when we want to put these things so other people can use it, we want to be able to make these usable by other people, right? We don't want people to have to set these things up. And especially important when we want to put these on Mosaic data sets. When we put these inside of Mosaic data sets, we don't want the user to have to go through and define what's going into what parameter. We just want it to know. We want the Mosaic data set. If I have a bunch of stuff in a Mosaic data set, I want to be able to apply that template, and I want to go through the Mosaic data set and find what's going in there without the user having to interact and define that. So we can do that. Raster function templates, RRFTs are very lightweight. We can use them everywhere. We can use them on image services. We can use them in ArcMap. We can use them all over the place. We can actually even call them in the Python API now. I think they built that into the Python API. So, like I said, one of the more advanced workflows, not necessarily for the end user, but for you as the image manager, is to add these to a Mosaic data set. And I'll quickly show you how to do that in a bit. We can actually use these in batch function editor too. So if I have 100 records in my Mosaic data set, I can actually use this batch function editor to add it to every item. You don't have to manually go in and add it to every item. So there's a GP tool that does that. So here is a basic function template in Pro, but same thing in 10. So here I have the name of the template. I'm not going to go over all this stuff, the description, the help. The more important thing is the type. So we can actually set item group as the type of a template, and that'll actually go and, like I said, go through a Mosaic data set and grab items from a Mosaic data set and pump them into that function template. So as an end user, I apply the template. It just works. Definition query, we can actually query which records we want to use in the template as well. And then we can add a thumbnail just for ease of use. So I have a Python raster function that actually requires several inputs. So it's gonna require like cloud ceiling, heat index, snow depth, temperature, visibility. But again, I don't want the user to have to know how to build these things. So I'm going to set my template up so that my Mosaic data set just knows. So in order to do that, you can do this item group thing. And when you set the template to item group, it'll actually open a few other parameters. And you can actually go in and set the field name. So the group field name is like so I have a group of rasters for date 1 and a group of rasters for date 2. You can set your group field to be the date. And then the tag field name, you can see this tag field name is the items in the group. So if I have December and February as my group, then I can have all these individual rasters with tag fields in that. So I can like further query it. So say I only want to do I only want to do this for December, and I can do that through the group name and tag field. For my demo, I only have one set of rasters for one date, so really only I need to set is the tag field name, and that's going to be the name. So I have a field in my Mosaic data set called name, and it has each different raster that I want to ingest into this template. And then in my template itself, I'm going to say, okay, I just want cloud ceiling to go into my raster, is my raster. And I'll show you how to do that as well. So I'm going to do a quick site suitability analysis. This could be used for anything. I was working on someone in the military with this, so I thought I'd use it. I guess we could use any type of suitability analysis, but I just had the data and it was easier. So I have a bunch of rasters and weather variables, and I have a remap table. They had a big remap table, and they wanted to find ideal areas for certain operations. So they had this giant table, and they had a bunch of rasters in it. And they said, okay, if I want to do air defense, the ideal temperature is between X and Y. And between those, if it fell in that range, and they wanted to remap it to a particular value, and they wanted to determine what areas were ideal for a particular operation, given these parameters. So here's what the template looked like. They had a bunch of weather rasters in a Mosaic data set. They had a bunch of remap functions, which were done in Python. So they had a Python raster function. It crawls through that remap table, remaps. And then they did cell statistics, which is an out-of-the-box function. So these are all Python functions, and this is an out-of-the-box function. So the cell statistics just added the stack together, so that if they had like a 1, a -1, a +2, and they added them all together, then it came out with a remap value that was either ideal or not ideal for a particular operation. So that's what the cell statistics operation did. So here's the basic code. I'm just crawling through a remap table, and I'm getting values from it, and I'm remapping it based on what's in that table. So that's really all it does. It's just a bunch of if and else if statements to determine what the remap value is and apply it to that raster. So pretty basic code under the hood. It just does a lot. So let's take a look at that. Hopefully this works in 10. So I have a raster, or a Mosaic data set here. Let me remove this, zoom to it. Horrible color. Okay, so I have a Mosaic data set with a bunch of rasters in it. You can see I have several rasters. Here's the name field. And I also have a Mosaic, a processing template applied to it. So if you go into here, go into the properties, you can actually add a bunch of processing templates. I have a processing template for each type of operation. Let me open this up. So these are all Python functions, these cloud ceiling. So I'm actually passing in a table, the thresholds table, the CSV, the from field, the to field, and then the target field. So from this to this, output a particular value. So these are just a bunch of Python functions sitting in here, and then a cell statistics function. And I have all these templates applied to my Mosaic data set. And let me show you where I have, so I have it set to item group here, and you can see I have group name and name. The most important thing here is the name, because the name is what I'm going to use to pass into the raster field. And if you look at the individual functions here, I'm actually getting that name. So I want cloud ceiling to go into cloud ceiling in this Mosaic data set. Or for visibility, I want visibility to go into the raster, right? So now as an end user, I don't need to know anything about this. I can publish this as an image service as well, and it's the same process. So as an end user, I'm taking the Mosaic data set, and I actually see all my templates in here, and I can just choose one. I can apply it, and it just applies a template. So as a user, I have no idea what Python is. I have no idea how to perform this. I just have to choose the template. You can kind of see, I actually even put it like an attribute table function on there so it labels it properly. So you can now tell, okay, this area here is optimal for a particular operation at a particular time. Okay, so let's dig a little deeper. Additional considerations. So when you're building these things, you cannot use ArcPy. You can use ArcPy. I shouldn't say that. I've never tried it. But you want to avoid using stuff like GP tools. Don't keep these things as arrays. Use NumPy, use SciPy, use scikit-image. Don't put it into a GP tool because it'll just be slow. We haven't seen a lot of significant improvement in performance with Python. I don't know if you guys use Python. Most people are just using it to compile their code so people don't see the underlying code. Also, do not try to avoid looping through the array. So for I in array, don't loop through each pixel in the array because that's going to get slower too. Again, you want to stick to the NumPy and SciPy and array functions. It's just going to slow things down. It's not that you can't do it. It just takes out some of that on-the-fly processing. It's going to take a little longer to process if you loop through it, especially if the array is giant. It can take time. Python versions. So for the only thing you really need to worry about is if you're going between Pro and desktop, it's that 2.7 and 3.6. There aren't a lot of differences, but there are a few things like print statements that you just can't have in there. That's about it. I don't really need to talk. Make sure you have package dependencies installed. So if you're going to publish this to ArcGIS server, make sure the server has these dependencies installed as well because it needs it. If you're going to do raster analytics, I don't know if you guys have gotten into that yet. You also need to have your raster analytics server has to have these package dependencies installed. So if you're going to be doing that, make sure you have them installed. I was going to do this. I can just talk about the Wellknown home folder. In Pro, we have this folder called the Wellknown home folder, and I'll show you what it is. We just tried to make this a little easier to distribute. So Pro doesn't do a really good job with relative paths. We were going to take the relative path road and just say if your Python file is stored near the template, then it's fine. But we decided to make this thing called the Wellknown home folder. And this exists in all of our applications. So if I go to Pro, Resources, Raster, Functions, this is the Wellknown home folder. We have some out-of-the-box Python functions that we ship with the software. You can actually create a new folder called Custom. And if you plop your Python functions in here, in Pro, it'll automatically show up in the function pane. So if you open Pro and you go to the functions pane, there'll be a custom folder, and it'll have all your Python functions in there. You don't have to like add them to the pane or anything. When using these in server, we just recommend that people put all their Python files in there. And this is because we didn't want people to be able to put like malicious code all over the place. This is a trusted folder in ArcGIS Server, ArcGIS Enterprise. So if you put all your Python files in there, it knows to go in there and look for them. So you don't have to do any of this pre-set up stuff. You just create the Python file, create the template with it, throw them both in this Wellknown home folder on server, Pro, desktop, and then it should work across the board. So that's the concept of the Wellknown home folder. It's just this trusted folder that we created to store all your Python files. So something to know when deploying. That's about it. We added some new stuff at 10.6 and 2.1, resampling type. So now we can like predefine what resampling type. If you want to use nearest neighbor, it's a list with value pairs or just a value. So you can set that. That wasn't doable before. Histogram X. So when we initially designed this, we built an histogram, but we were passing an incomplete histogram into the Python raster function API. We were only passing counts and the pixel values, so we made a full-on histogram that accepts min-max values and the size of the histogram. We called it histogram X. The reason we didn't just replace the old histogram is because we didn't want people who are already using this to be out of luck. So for people developing new Python raster functions, we recommend using histogram X. For people who are using it before and just didn't want to convert it over, that's fine. So that's new at 10.6 and 2.1. And we also support non-C contiguous arrays. We didn't do that before, and it was outputting something kind of wonky when people were using non-C contiguous arrays. But we added support for that as well. So like I said, go and explore our GitHub repo. Here is the URL. You can just type in Python raster function too, and it'll show. I think it's the first thing to show up. So look at the samples. If you have any questions, you can put them on. You can ask them on the GitHub repo. We're usually pretty active on that thing. Yeah. Feel free to collaborate too. We have a lot of people who, when we first started this, who were like sending in code samples and we were putting them up there. So if we can grow that repo, that would be great. The more the merrier. I try to add some every now and then, but I run out of time because I'm doing other things. But yeah, feel free to try and put your code samples up there as well. And that's it. Any questions? No, but I'll be at the island all week if you want to talk about it. And I can give you the slide deck as well. And try and get it to work in Pro. It's the same thing in Pro. It's just the raster island. It's right over, right when you come in the door. It's right by the 3D island. I think there's like 3 computers over there.